So here, let's draw a tree diagram to start. We have 3 fans, each with 3 settings. So your first fan, are you okay with O for off, L for low, and H for high? So that's your first fan. Then set in your second fan 3 options. And this is worse than the trumpet, right? And then your third fan, ooh, yeah. Ooh, yeah. Perfect. And there's 27. Now, of course, we could have counted all 27 of those by doing our spaces instead. We have 3 decisions to make. How many choices do we have for our first decision? 3. Then our second decision, 3. And then our third, 3. Multiply them all together, and we get 27. But if we had to list them systematically, then the tree diagram would be nice because you could just go across. Like you go across the top, and which is the first one you get? Oh. Right? There are some really good ones in here. This is my favorite. Whenever you have 3 fans, it's always nice to have the first one on low, second one off, and the third one on low. Okay. Okay. So this idea, because if you had 15 fans with 3 settings and you wanted to draw a tree diagram, it would get really crazy really quick. So the spaces idea is something called the fundamental counting principle. So if we highlight that in our notes, and basically what the fundamental counting principle says is however many decisions you need to make, draw a space for each of your decisions. So example that I'll use is before I come to school, I have to make a decision what clothes am I going to wear. Well, how many outfits would I have possible? First of all, I have to decide which pair of pants I'm going to wear. So I go to my closet and I have 8 different pairs of pants and I could choose one of them. Then I need to decide which shirt am I going to wear. And I have 30 different shirts. My closet is full of shirts. And I could choose, that bright yellow one with the big green monster on the back. I could choose that one. I should. I haven't yet. Okay? And then after pants and shirt, I need to choose some socks. Unfortunately, I only have 1 pair of socks. I wear them every day. Laundry day is tomorrow, if you can tell. And they're black. Yes. And then finally, I got to put on a pair of shoes. I got 5 pairs of shoes. So if we put this all together, what does this come to? A decent number. 1,200. 1,200. That means if I would randomly pick things, right? The polka dot pants with that yellow shirt with the green blob on the back, that could be an outfit. And if I listed every single outfit possible, even with only 1 pair of socks, I could have a different outfit every day for 1,200 days. And there's 200 teaching days in the school year, so that's good for 6 years. You'll never see me in the same outfit for 6 years. How many belts do I have? I should probably put belts in there. I think I have seven belts. So there we go. And that includes 8,400. You see, there's just that awkward day that I wear the black shirt, the black pants with the brown belt. Everybody's kind of like, what's going on? But it could happen. So we can count relatively large numbers quickly with the fundamental counting principle. This would not be fun with a tree diagram, especially when we get to the third item, the 30 shirts, and we'd have to do 30 things off of each branch that we had so far. It would get quite complicated quite quickly. But the fundamental counting principle, if we have a space for each of our decisions, and the number that goes into the space is how many choices we have, we can figure out the total number of possibilities by multiplying them together.